Alright, we'll be doing these two questions at once. The first one is, as part of a chemical analysis, a technician requires 100 milliliters of an accurate 0.15 moles per liter solution of sodium thiocyanate. In the pre-lab work, the technician calculates the mass of pure sodium thiocyanate. Okay, and then the mass required is in grams. So what it's asking for is, well, what is the mass of this concentration of sodium thiocyanate? Okay, so let's start. So first up is that 100 milliliters we'll convert to liters, which will give us 0.100 liters multiplied by the concentration of sodium thiocyanate, which is 0.150 moles over liters. And if you plug that into the calculator, it will give you a value of 0.015 moles of sodium thiocyanate. So now what do we do with this moles? What we have to do is we have to convert that moles into mass, which is in grams. So given our calculated value of 0.015 moles over liters of sodium thiocyanate, we need to multiply it by, moles, not moles over liters. We need to multiply that by the molar mass of sodium thiocyanate, which is 81.08 grams over moles. And remember, the secret to doing well in stoichiometry is to cancel out the undesired unit and have the desired unit on the numerator of the final step. So as you can see here, the moles will cancel out, and on the numerator we have the unit for mass, which is grams. So if you multiply 0.015 multiplied by 81.01, it will give us a value of 1.22 grams of sodium thiocyanate. Okay, now for the second question, which was, a solution is prepared by analysis by dissolving 4.9 grams of sodium sulfate in 250 milliliter of solution, and it asks for the concentration of sodium phosphate. So the first step is that 4.19 grams, we need to convert it to moles of sodium phosphate. So let's do that. So we're given 4.9 grams of sodium phosphate, and first step is we need to divide it by the molar mass of sodium phosphate, which is 163.94 grams over moles. And remember, if you forget how to determine the molar mass of a specific compound, for example, like what we're given, like for sodium phosphate, you multiply it by 3 times the molar mass of the given amount in the periodic table of sodium, multiplied by 1 times the molar mass of the phosphate in the periodic table, and 4 times the molar mass of the given value in the periodic table for oxygen, which gives us the total of 163.94 grams of moles. Okay, and when we calculate this out, again, stoichiometry, undesired unit cancels out, and we get the desired unit on top, which will give us 0.02987 moles of sodium phosphate. Now, given that value, what we just calculated out, which is 0.02987 moles of sodium phosphate, it asks us to determine the concentration of that. And we were given the volume of 250 milliliters. If we convert to liters, it's 0.250 liters, so we just divide it by 0.250 liters, because our desired unit for the concentration is moles over liters, and we divide those two values, it gives us a value of 0.120 moles over liters of sodium phosphate.